This is George Gamow, a funny man. Gamow is originally from Russia but immigrated to America in the 1930s. He was originally a theoretical physicist working with particles, but when he moved to America, like Hoyle, he shifted gears to become a writer. Clearly, Gamow and Hoyle did not get along, especially after Gamow published a book mocking Hoyle. Gamow created the first Big Bang model of nucleosynthesis. Gamow was originally inspired by the father of the Big Bang theory, Lemaitre. Lemaitre and Gamow had similar ideas in that Lemaitre proposed that the universe began as a primeval atom in which all the matter it contained went through superradiation that created the matter we see today. Gamow similarly proposed after neutron decay, where hydrogen atoms are formed, heavier atoms began to build up, creating matter. This is Fred Hoyle. He is an astronomer from Cambridge University in England. In 1940, Hoyle began studying the inside makeup of red giant stars while he had began his steady-state theory. Hoyle started out as a mathematician but shifted gears to becoming a science fiction writer. One midwinter day in 1953, Hoyle decided to go into the Kellogg Radiation Laboratory at Caltech. Hoyle didn't get the warmest of welcomes from the other scientists at Caltech, but he knew what he wanted: more accelerator time. Hoyle was determined to do something no other physicist had done before. He wanted to discover how larger elements originated in the universe. Hoyle finally was able to convince one of the researchers, Ward Whaling, to give him more accelerator time. Hoyle did test the Big Bang theory, and he made sure this was known through radio stations and his infamous speeches. Hoyle created his steady-state theory in 1948 with a mathematician and astrophysicist. And now for the most important person. This is Judge Cardston. For a long time, there has been a considerable debate over which theory correctly described the formation of matter: Hoyle's steady-state theory or Gamow's Big Bang theory. Judge Cardston will decipher which is deemed guilty.
Hoyle and Gamow, you are here today to discuss your theories on the steady state and the Big Bang theory, and how the matter in the universe was created. We'll start with Hoyle. You have 1 minute to speak.
My theory, the steady state, proposes that the universe is the same everywhere, eliminating the need for a beginning. Instead of the universe beginning in a bang to explain expansion, the universe is continually creating matter that results in expansion. The universe constantly but slowly creates hydrogen. It doesn't have a time problem like someone else's theory.
Very insightful, Hoyle. Gamow, now it's your turn.
My theory, the Big Bang theory, suggests that the universe is constantly expanding and continuously getting less dense as it goes. This means that a single primeval atom could have rapidly formed hydrogen through neutron decay, and then every other element through neutron capture. And at least my theory obeys the law of conservation of mass and energy.
Now that you guys got your points across, we'll discuss with the court about our decision. We have made a decision. You're both wrong. Well, wrong in the sense that you shouldn't be arguing. Both your theories are actually necessary to explain the origin of matter. Hoyle, your theories help to explain elements through iron, and Gamow, your theories help to explain elements heavier in iron. While it seems that you two seem to be working against each other, actually, you've been working with each other.
Yeah,
So from now on, I'd rather see you two working with each other instead of against each other. Court dismissed.
Although there was a feud, combining both theories allowed scientists to further their knowledge and research. Both theories helped each other and were necessary in explaining the beginning of elements. This is a great example of how science needs both theory and observation. After all this chaos, Gamow turned to biology and the study of amino acids. He additionally turned back to writing and creating books and articles on cosmology. In 1964, Hoyle worked with Cambridge colleague Roger Taylor, discovering that stellar processes could not explain the amount of helium. This kept him occupied. Both Hoyle and Gamow did not give up on their studies. The end.